I'm Nurul Hazrina binti Nordin from MC3 STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to Chapter 3 of our micro-credential course entitled Working with External Libraries. This chapter is part of the course outcome of the Raspberry Pi programming course, which involve integrating Python programming with hardware, specifically using Raspberry Pi systems, Raspberry Pi 4, and microcontrollers like the Raspberry Pi Pico. In this chapter, we will focus on working with external libraries, specifically using Python libraries to interface with an OLED. Throughout this module, we will cover installing the necessary libraries to enable communication with an OLED screen, displaying text and graphic on an OLED using Python, and interfacing with external hardware through Python libraries. In Python, external libraries are pre-written codes modules that helps us perform specific tasks without writing everything from scratch. When working with hardware, these libraries make it easier to communicate with devices such as sensors, display, and motors. For example, instead of manually programming how an OLED display receives data, we can use the SSD1306 library to simplify communications and control. This saves time and ensures compatibility with different hardware components. Before we can use OLED display with Raspberry Pi Pico, we need to install SSD1306 library, which is specifically designed for I2C based OLED screens. This library provides functions to write text, draw shapes, and clear the screen easily. Here's how to install it. Download the SSD1306.py file from the trusted source like GitHub, in which you can do so via UMP STEM Lab GitHub. Open Tony IDE and connect to Raspberry Pi Pico. Copy the SSD1306.py file into the Raspberry Pi Pico file system. Import the library in your Python script using import SSD1306. Once installed, this library allows us to send commands to the OLED display using simple functions like text, show, and fill. Now that we have installed the SSD1306, let's write a simple Python program to display text on the OLED screen. Here's what each part of the code does. First, we insert the command to import the SSD1306. Then, we initialize the I2C communication to connect the OLED with the Raspberry Pi Pico. The screen is cleared by using this fill 0 function. The text Hello OLED is displayed at coordinates 1010. Take note that this 1010 refers to the pixel coordinates X and Y. The show function updates the screen to make the text visible. This is the fundamental way to display information on the OLED. You can modify the text to show sensor values, notifications, or status messages for your project. This is an example of Python code. Follow the instructions sheet for activity 5A to display graphics on OLED. Beside text, the OLED display can also show graphics like shapes, lines, and images. This is useful for creating visuals, indicators, dashboard, or even animations. In this example, we first clear the screen. The text graphics example is displayed at position 1010. A rectangle is drawn using rect 30, 20, 50, 30, and 1, where 30-20 is the starting positions of the rectangle. 50-30 is the width of the height. 1 means the shape is drawn in white on the black background. Finally, show updates the display to make the drawing visible. With these functions, we can create interactive visual display that react to real-time data, such as progress bars or graphics meters. Now that we understand how to display text and graphics on OLED screen, let's take a step further by integrating the external sensor, the BME280 environmental sensor, with our Raspberry Pi Pico. The BME280 is a compact, high-precision sensor that can measure temperature, atmospheric pressure, and humidity. It is widely used in weather monitoring, IoT applications, and smart home systems. In this example, we will read real-time data from the BME280 and display it on the OLED. This will help us to create a simple environmental monitoring system using Python. Let's have a look on how the code works. First, we initialize the I2C communication for both the OLED display and the BME280 sensor. The OLED screen will act as our user interface to visualize the sensor readings. Next, we create a loop that continuously reads sensor data, including temperature, pressure, and humidity. We then clear the OLED screen and update it with the latest readings, ensuring the display is always showing real-time data. Finally, we introduce a delay of 2 seconds before the next update, preventing excessive refresh rates while keeping the information current. This approach is fundamental in IoT applications, where devices must interact with external sensors and provide real-time feedback to users. Let's summarize what we have learned for this chapter. First, we look into external libraries. External libraries make it easier to interact with the hardware components. The SSD1306 library allows us to control OLED displays with Python. We learn to display text and graphics on the screen. Python libraries also help us connect with other external hardware like sensors. Mastering external libraries opens the door for more advanced projects, such as IoT devices that display real-time sensor data, smart home automation systems that provide visual feedback, graphical interfaces for embedded applications. With this knowledge, you can now integrate OLED display and sensors into your Raspberry Pi projects.